And we are live. We should be live. Okay, so welcome, boys and girls, to my second attempt at my first stream. The first time I failed miserably because the audio was too loud. So I tweaked the settings in OBS, and hopefully this time I won't have as many issues. Now I would like to apologize in advance for any background noises you may be hearing. I'm doing my best to suppress those in settings, but we'll see. We'll see how it goes. So as you probably would have guessed from the title of this stream, we are going to have fun with Terraform today, and the plan is to essentially deploy a basic API, Go API that I've written, and deploy it on Kubernetes to a Kubernetes cluster that will be hosted on DigitalOcean. We'll do that using Terraform. So we will deploy a load balancer using nginx, Ingress. We will set up our domain and DNS settings automatically. So we will point the load balancer IP to our domain name that will be managed by DigitalOcean. We also will make use of TLS through cert-manager, and we will also deploy a Postgresql high availability chart, all of which will be done automatically through Terraform using Helm, the Helm provider, and Kubernetes. So yeah, so I guess let's crack on with this. Before I get started though, there are a few prerequisites. So you are going to need a DigitalOcean account. If you don't have one already, I highly suggest you create one. You will get, if you use my link that I will put in the description, this is being streamed on Twitch, so I'll add the link to the chat. But if you are watching this on YouTube, there will be a link to my DigitalOcean referral link in the description. And in the spirit of full transparency, if you use it, and I believe if you spend $25, I get a kickback of $25 in free credits. So I'm not even getting paid cash. I'll be able to just use the credit to, you know, create more, I guess, more content. So that's a good way to support the channel and the content I create. So once you have that, you're good to go. You will also need a domain name. I use Namecheap, but you know, whatever registrar provider will do. The only thing you will need to do though is you will have to look at the documentation for whatever, you know, provider you use, and find the name server category of name server section, and then add these 3 entries, ns1.digitalocean.com, 2 and 3, and don't forget the trailing dot at the end. Once you've done that, the next thing you want to do is install a utility called doctl. doctl, it's the DigitalOcean command line interface, and there are many ways to install it through macOS, Ubuntu, Snap. You can essentially just download the binary and do the whole thing yourself. You can also, if you're on Windows, we also have your instructions. Please forgive me for the loud motorbike that's just driving past. Okay, so also as a side note, I am running on all of this will be done on Linux, on Ubuntu. So I'm running inside a Vagrant box right now. It's Ubuntu 2004. So I've installed it using Snap and blah blah blah, and I've done the whole like kubeconfig thing and X, Y, and Z. Now before we start, we need to create a personal access token. So we'll generate one. We'll call this stream demo, Fisher stream demo. This will be valid for 30 days, but you can set yours to a year to never expire if you want. And then generate token. Now, obviously, this token will be immediately revoked after the stream is done. But you have to be extremely careful because you can only copy it once. So what I suggest you do is you add it to your bash rc or fish config. I use fish, so I'm gonna add it to my fish config like so. And so I'm going to do set -x do token. As you can see, I've already done this, but I'm going to do that. Then I'm going to pipe that to t -a, and then .config fish config .fish. Okay, so now if I do tail -n1, boom, I have my fish config, and if I echo do token, it's working. Now the next thing we want to do is we want to authenticate. So we'll do doctl auth init, and then we'll paste the token, and then we're good to go. So these are the prerequisites for this to work. So let's crack on with this now. We'll need Terraform, so I'm going to create a directory in temp, and I'll call it pocket.us. Yeah, pocket. Oh, not cd. I want to make their pocket.us. This is the name of the app, and so I'll cd now into temp pocket.us. Pocket.us. Thank you very much. Right now it's empty. We'll create two directories. We'll create a Terraform directory and a Kubernetes directory. And inside the Terraform directory, we will create a main.tf file. We'll open that file, and then we will essentially get started. So if you're not familiar with Terraform, it uses its own language called HCL. I believe it stands for HashiCorp Configuration Language. It's very basic. It's sort of like JavaScript if you've ever written JavaScript. So the syntax is very simple. Every main.tf file should have this block. So required providers. It's a sort of sub-object of this. Now, how do we know how to use DigitalOcean with Terraform? Well, we'll go to the Terraform registry. Terraform registry, boom, and then we'll see. I already have the page loaded up, but I'll go to DigitalOcean, DigitalOcean/DigitalOcean. We'll click that, boom, click use provider, and then all we have to do is just copy and paste. We could have copied and pasted everything here, but we'll just copy and paste this. And then we'll go back here, and then we'll just paste it here. So this is going to tell Terraform to use the DigitalOcean plugin or provider. This will help us. This is going to be required for us to interact with the DigitalOcean API and create and delete and update resources. So once we have that, we want to configure that DigitalOcean provider. And we'll do so with a provider block. So provider, DigitalOcean, and this takes a token, which we will set as var do token. Now, we'll create a variables file.tf. So we'll open it now, variables.tf, and we'll just declare the variable do token. It's going to be empty, and what's going to happen is we are going to create another file, because this variable is extremely sensible. we will essentially add it to our Terraform.tf vars file. And so what we'll do is we'll essentially do do token like that. So we've called it do token instead of docli token, but we'll escape the quotes, and then we'll send it to terraform.tf vars. And if we cat terraform.tf vars, we have that. And the reason why I did the whole thing with the quotes is because it's required that variables are surrounded in double quotes. I'm not sure if it's double quotes or single quotes, but if you don't do that, you'll get an error, even though the token is valid. So be careful with this. Okay, so well, now we know how to use variables. We've declared it, and we've set up the provider. So now all there is left for us to do is to do a Terraform init. So because right now we've declared that we want to use the DigitalOcean plugin, but we've not we haven't downloaded it. So we need to do Terraform init, and this is going to install and download and install the plugin. So now that we have it installed, by the way, I use TF as a shortcut for Terraform within my fish shell. I've added an alias. I suggest you do the same. Okay, so we have added the DigitalOcean provider. Now what we want to do is we want to add the first element is a domain, right? So we'll go back to the DigitalOcean console, and if we go to networking, domains, you can see we can add a domain, right? And if you remember, I've set up my domain to point to DigitalOcean's name servers. So essentially what is left for us to do now is we'll add that, or I guess register that domain on DigitalOcean. And the way we'll do this is if you look at the documentation and resources and we scroll down, you can see we have this domain resource. So even the comment even explains that it's used to create a domain. So we'll copy that because we're lazy, and we'll paste it here. We'll call this pocket.us. We don't need an IP address. We will set that up later, and then in here we will have our domain name, var domain name. So we'll create a variable, var variable domain name, and this is going to be of type string, and the default value is going to be pocket.us, just like that. So we'll save, and we will plan. We'll do a Terraform plan, and if you look at the output, it says Terraform will perform the following actions. It's gonna DigitalOcean domain will be created with a resource, and as you can see, it's got the ID, a TTL, and a URN. And if we go back here and we look at the attribute reference, ID, URN, TTL, and these attributes are exported, so we don't know them ahead of time. Of course, you can't know the ID of the domain before you've created it. Doesn't make sense. So that's that. So this is done, and in fact, to verify that this has been done, if we refresh here, you can see, hopefully, of course we've just planned, we didn't do apply, so we'll do tf apply. This is going to prompt us to confirm. Now it has been created, and if we refresh now, hopefully, yes, we do. We should have the domain, which we do. If we click, as you can see, the value So with the NS, the records, we have 3 name server records, and they essentially all direct to the NS1 DigitalOcean.com, blah blah blah. We will be able to create also to add a record to or to add a record essentially to our domain, and we'll do that once we set up Ingress, and we'll do that automatically. So we won't even have to, you know, type it all in and blah 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 and all the rest of it. So next thing we need to do is we'll create the cluster, right? And so the way we're going to do this is using a Kubernetes cluster block. We go back to the documentation, and we scroll further down. You see DigitalOcean cluster. So we've got basic example, we've got auto scaling example. What else do we have? We have an auto upgrade example. And this is interesting. This we'll need this very soon. We'll use the exec credential plugin, because we will need to be able to authenticate to the Kubernetes cluster once it's created. So we'll keep that at the back of our minds, and then we'll come back to that. Argument reference. So let's go to attributes reference. As you can see, if we look closely, it will export a kubeconfig file with all the necessary information we'll need to be able to authenticate. So go back all the way up. We'll copy this resource. We'll paste it. First thing we need to remove is this whole taint thing, because we don't need that. And okay, so we'll name it Pocket Cluster. The name is going to be var.cluster name. Region is going to be var.default region. The version is going to be var.cluster version. And then the node size, so var.node size. Actually, let's delete that because we don't really need it. And then we'll do var.node count. So we'll create these variables real quick. So we had, what did we have? We have a cluster name. So cluster name, it's going to be of type string, and default is going to be pocket cluster. You have to give it, it only accepts hyphens. Underscores are legal as far as I'm aware. I've had issues setting up clusters using underscores. Then what else do we have? I think we have default region. Default region. It's a string, and it's going to be lon1. It's the closest to me, London. Again, if you want a list of regions, you can do doctl compute region list. And this will give you a list of all the available regions. And now that I'm thinking about this, maybe we could do Kubernetes region list. Let's see if it works. Nope, it doesn't. doctl Kubernetes. What options do we have? Options. Okay, let's do that. Kubernetes options, regions. That actually would be more appropriate. And what we need is the slug. So for me, I use London 1 because it's closest to me, even though I'm not in London. Okay, so go back. Whatever, let's go back to Vim. Okay, so we've got the default region. We need cluster version, so we'll do cluster version, and that is going to be doctl Kubernetes options versions, and we will use this one. We'll use, it's not the latest as of the time of, I guess, recording or doing this, but you know, whatever. We'll need the node size. Node size, so node size, and again, we look at the available sizes. Kubernetes options, sizes. I will go with S2 vCPU 2 GB, but again, you can, you know, look at the list and choose whatever fits your needs. What am I doing? All right, so that's the node size, and then I think we had the node count. Node count, and node count is not a string; it's a number. Whoop. It's a number, and it's 3. Again, you don't have to create 3 worker nodes. You can create 2, 15, 1 if you want. Adjust those settings to your particular needs. So I think we're done with the Kubernetes cluster configuration. So if we do tf plan, as you can see, it will create DigitalOcean. So 1 to add, 0 to change, 0 to destroy. It didn't recreate the domain because it's already created, and we have the terraform.tf state file that's been created, and this is what keeps track of the current state of the app. So yep. So we can review all the changes and blah blah blah, and hopefully we can apply now. We'll do auto approve to just skip the prompt, and this is going to go ahead and create the cluster for us. I think it's going to take a couple of minutes. So in the meantime, in the chat, if you have any questions, I'll be willing to answer them. Let me know if the font size is big enough. On Linode, which is the service I initially wanted to do this demo with, well, it's kind of hit or miss. It's been hit or miss. I've had a weird experience with it. It's quicker to sort of spin up, but like half of the time it just wouldn't allow me to authenticate. So we're going to use that trick from the documentation, like that, to do just that. But before we do, actually, yeah, let's have fun. We will output the kubectl file. Actually, we'll need it. So if we go back to the attributes reference and kubeconfig.0, so this is an attribute that is being exported by the resource, the Kubernetes resources, Kubernetes cluster resource, and so we can access that through an output variable. So if we do output, and we'll call that my kubeconfig, we'll give it a value of, so the value is going to be Kubernetes DigitalOcean Kubernetes cluster dot, what did we call it? Pocket cluster. I think it's raw config. No, it's kubeconfig. It's kube_config .0.raw config. We go back, we have kubeconfig.0 and then raw config, the full contents of the Kubernetes cluster configuration file. So that's that. Let me actually go to Terraform output variables. Let's look at this, and let's look at output values. Declaring an output value. Optional arguments. Output sensitive depends on. So we can have a description. We'll set it to sensitive, so that it doesn't essentially spit it out for us, and it doesn't depend on anything really. I mean, it does kind of depend on the DigitalOcean cluster to be up and running. So we'll set it to sensitive equals true, and hopefully once the kubeconfig thing is once the Kubernetes cluster is all up and running, we'll be able to get that using Terraform output. Well, let's get ahead of the curve here, because the next thing we'll do once this is all created is we will install the nginx Ingress helm chart, and for this we have helm provider. So if we go helm, HashiCorp helm, boom, that's the official one. We'll go use provider, we'll do this, copy that, go back all the way up, we'll paste this just like that, 16 and I don't like that. Nope, what are you doing? Alright, so we'll fix the indent. Nope, what are you doing, man? Behave yourself. Okay, wow, finally. So we have that, and then we will set up the helm provider. And so if you go to the documentation, data sources, example usage, authentication, explicitly by the helm provider can get its configuration two ways: explicitly by supplying attributes to provider block. This includes using a kubeconfig file, supplying credentials, exec plugins. We'll use that, and then we'll essentially copy this. We will copy this, and then we'll do that. Oh, nope, that's not what I wanted to do. Alright, so we have this. We'll set it to debug. By the way, debug equals true. You don't want to do that in production, but for us, it never hurts if we want to troubleshoot. Okay, so that's not the endpoint. This is going to be, go back. This is going to be, okay, so this is going to be DigitalOcean Kubernetes cluster dot pocket cluster dot endpoint, right? And this is going to be DigitalOcean dot pocket pocket dot pocket cluster. There you go. Dot cube underscore config dot 0 dot cluster CA certificate, and then we don't need this. Actually, that's not what we want. What we want is we want to copy the one we had here. So where is it? Where is it? Where is it? That's the one. That is the one. So we'll copy this, paste it. We'll get rid of that, and then we'll fix the indentation. Nope. Why do you keep moving? God. All right. DOCTL, blah, 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 blah. And that's the reason, by the way, that's the reason why we've installed DOCTLs, because it's going to generate an token for us. Because apparently the authentication tokens are very short-lived, and so we may run into a situation where if we want to, say, install an Ingress or Helm chart or whatever to the Kubernetes cluster, that the token would expire, right? So something like that. So this ensures that we have a valid token and that we never get an error. Okay, so we have installed the Kubernetes, the Helm provider. We've set it up, we've configured it, so we'll need to do Terraform init. Let's just do Terraform init, and it's going to download and install the Helm plugin provider. And if we go back now to our control panel, if we go to Kubernetes, we have a running cluster. So the name matches. We have 3 nodes, right? If I go to droplets, I think we can find them here as well. Nope, that's not droplets, that's functions. Go to droplets. There you go. We have 3 worker nodes with their IPs and their tags, and they have 3 more tags. Okay, so we'll go back to network. Nope, we'll go back to Kubernetes. Kubernetes, please. Okay, and we'll stay here for a while on the resources tab. All right, so we have everything right. Oh, actually, let me show you how to do the whole TF output thing. So we'll output the raw version of my kube config. No, do we need to do, no, actually need to do TF apply. Shouldn't we do that? No, actually, let's just try and do this first and see if we can get it to work. So we'll do my kube config. I'm curious, and we'll put that kube config, and then we'll chmod 600 kube config. Oh, okay, work. If we do wc-l kube config, we have 6 lines. TF, oh, okay. So it didn't work. So we need to do TF apply again then. Yep, alright, so changes to output, my kube config. So if we now do that again, and we do wc-l, now we have 17 lines and it's working. And if we do export kube config, this, and we do kubectl get node, yep, it worked. Cool. So we have it working. So now we want to install nginx, the Ingress controller. So the way to do that, if we again go back to the documentation, we'll go to resources, Helm release, and boom. So we'll just copy this. We'll copy that. Paste this here. We'll add a closing curly bracket. Okay, so we have a Helm release. We'll call this one nginx ingress. We'll call it nginx ingress. The repository URL is kubernetes.github.io slash what is it? Ingress. What is it? Yep. Kubernetes.io, kubernetes.github.io slash ingress nginx. So that's the one. Whoop. Go back. Nope. Slash ingress -nginx. Okay. And the chart is called ingress nginx. We don't need a version. However, it does depend on our Kubernetes cluster to be up and running. So we'll do that. We'll set that up. And as you can see from the documentation, we can add variables through the set blocks. And this sort of matches the original Helm syntax from the command line. So you can do helm install nginx, and as you can see, you can do --set and then add a we can add a variable. And well, interestingly enough, this is exactly the variable we are going to add. So controller.publish service.enabled true. And this is because we want our controller to advertise the load balancer public IP, so that we can retrieve it and then use it to essentially create a record that is going to point to our domain name. All right, so let's do that. In fact, let's take the opportunity to sort of install the Kubernetes provider. So we'll go back, type in Kubernetes, and hopefully, yep, HashiCorp Kubernetes. So that's the official one. We'll do use provider. We'll again copy the whole thing, not the whole thing, but the block, and then we'll paste. All right. Now, interestingly, this didn't mess up my indentation, and so now we need to again configure the provider. But we have the whole thing set up for us, so we'll just copy and paste it, and then we'll just remove the data attributes like that. df that like that. We'll also replace this with Pocket Cluster, this, and then essentially we'll do .0, not this. Now hopefully this works. Let's do no, before we do that, let's actually grab the no, actually, do you know what? Let's first do a tf init. So we'll an attribute name is required after dot. Line 31. What happened? Oh, yep. Got that. Do it again. tf init. We'll install the Kubernetes provider. Right, it's done. We'll tf plan. We'll do this chronologically, and I want you to see like every step of the thing happening. So okay, boom, it's created the plan. Okay, we're happy with the variable. Now we can do tf apply auto approve, and it's going to apply the it's going to essentially install the Helm chart for us. What's happening? What is happening? Okay, it's creating, and soon enough, we go back here. Soon enough, we'll see under the resources category or tab subsection, we'll see a load balancer being created. We can go to networking, load balancers, and boom, it's created a load balancer for us. So it's in the process of being provisioned. So yep. So while we wait for this to finish, we will actually go and grab the IP of that service. So we'll do data. Actually, go back to the Kubernetes documentation. So we'll do documentation. We'll go to, we'll type service v1, core resources, data sources, service v1. So we'll do this. We'll copy, and then we'll paste that here. We'll call that nginx. Well, we'll call that Ingress SVC. And then this is going to be what is it going to be? What is it going to be? That's a very good question. SVC name. I'm looking at my notes because I came prepared, and so we'll go add a variable. So nginx SVC name. Okay, and so okay, so we'll add the variable. So it's called nginx SVC name. It's of type string, and it's called it is called, all right, so it's a bit confusing, but it's called nginx ingress hyphen ingress hyphen nginx hyphen controller. So nginx hyphen ingress hyphen nginx hyphen controller. Wow, what a nice name. Totally not confusing. So now that we have this, we can essentially go, oh, by the way, we want this to depend, it depends on our helm release dot nginx ingress thing to be provisioned. We don't want that to we don't want to grab the IP for a service that doesn't exist yet. So okay, so we have this now. So now that we have this, we want to create a record, right? And by the way, just to verify that this is actually working, we'll go back to the control panel. So it's all created, blah blah blah. We've got the settings here. Okay, let's go back to load balancer. Now we have the IP address, but if we do kubectl get service, you'll see nginx ingress dash nginx controller blah blah blah. We've got the cluster IP and the external IP that matches the one that we see here. So what we're going to do is essentially we're going to grab that, extract the external IP from it, and then essentially populate an A record for our domain. So if we go back to our domain, all right, let's do this here. If we go back to the documentation for DigitalOcean domain, if we type in, I think it's record, yep, DigitalOcean record, boom, and we can grab that at an A record. So we'll do this, we'll paste that, we'll call it main record, because we're not going to add a subdomain. We'll just do pocket.us.ids, type A, name is going to be @ and the value is going to be data.kubernetes service v1 .pocket, what did we call it actually? What did we call it? Ingress service. So we'll call that ingress underscore SVC. Status. Actually, let's go back. Where is it? Boom. If we go to attributes, status, status, right? Status is a list containing the most recently observed status of the service, populated by the system, read only, more info, blah, blah, blah. So status, it's a list, so we'll have to access it like a list. So we'll do status 0, load balancer 0, ingress 0, and then we'll extract the IP. IP is set for load balancer ingress points that are IP based. So we'll do that. So we'll do status dot 0 dot load underscore balancer dot 0 dot ingress dot 0 dot IP. Okay, and this depends on our data dot Kubernetes service v1 dot ingress service to be ready. And now hopefully if we do a TF plan, we shouldn't have any issues. Hopefully. And again, forgive the background noise if you can hear that. Boom. Okay, so we don't seem to have any problems, so we can safely run TF apply, auto approve. Hopefully. Yep. It is done. And so just to have fun, if we go back here, we'll go to domains. As you can see, domain points direct to the load balancer. We'll create a pocket.us, and as you can see, boom, we have the A record created. And just to check that it's populated, I'll just do a quick curl of http. Of course, that's not pocket.us. Yep, we get the 44 not found from nginx. Let me actually have fun and do w3m and use pocket.us. Yep, 44 not found nginx. Great. Okay, so next thing on list, now that we have our ingress controller set and our domain that points to the correct IP, we want to deploy Postgres. And so we'll do that. We'll do that just now. All right, so it's going to be the same dance essentially. So we'll just have to copy and paste the whole thing. Yeah, so we'll copy that and we'll call this Postgres. Yeah, we'll just we'll call it Postgres. So this depends on the cluster being set up and running. We'll call that Postgres. The chart is going to be PostgresQL-HA, and we'll get that from charts.bitnami. I think it's .com /bitnami. All right, we don't need this, I believe. And we'll provide values. We'll put a values file, and this is a list of value files, but we'll go file case psql values.yml. Nope. All right, just like that. All right, so if you're confused, we'll go back to the helm thing. As you can see, we can provide values here, and we just have to pass the path to the file, and this again matches the helm install. Let's do Postgres. Is it -f? Yep. Nope. Well, as you can see, I mean, I've done this before, but you pass the -f flag and then you give it the values, they'll override the default values. So we'll do just that. We'll do psql values.yaml. In fact, that's not, yep, that's that. It should be yml, not yaml. And so we go back here and we do psql values. Open it. Why won't you open? Thank you. All right, so let's go to GitHub and go and find the Postgresql high availability package by Bitnami. And if we scroll down, we'll see parameters. The global parameters that we're interested in is the storage class, the username, the password, and a database name. So we'll do that. So we'll essentially override the defaults. So we'll go global, and we'll do storage class, and this is going to be used to create the persistent volumes and all the rest of it, stateful sets and whatnot. To check what storage class is available to us, we'll do kubectl get sc for storage class. Boom, we'll get that name, do block storage, we'll paste it here, and then we'll go back to PostgresQL. I think it's PostgresQL, isn't it? Yeah, it's global.postgres.username, but I'll just do that. So I'll do Postgres and what is it? Username, password, and database. Okay, so username, password, and database. Now, just a quick note: you probably don't want to have this checked out to Git because it's going to contain a password, so it's very sensitive information and you don't want that to be leaked on the internet. For the purposes of this demo, I'll just go with titoxufisha.xyz, it's my website, and the database name is going to be called Pocket Prod for production. So now that we have the file created, we can go back here and deploy the Postgres the Postgres helm chart. So we'll do tf, we'll actually do tf apply. It's going to do a tf plan anyway, so hopefully we don't have any errors. I don't think we have made any, so yep. All right, so as you can see, it's creating the values file as YAML, blah, blah, blah. We'll enter a value, we'll say yes. And this should hopefully install. And when it does, we'll be able to see, in fact, let's go and do just that. Let's do watch get pod. Oh, export. Boom. Let's do that. kubectl watch. kubectl get pods. And boom, it's creating, as you can see, the HA pool. All of them are running now. They're just not ready yet. They're just not ready yet. They will be soon. Okay, one is ready. First one is ready. And I think they're being created synchronously. Yep, as you can see, 0 got up first, and then 1, and then 2. So okay, it's done. We'll do kubectl get stateful set. A stateful set has been created. We'll do get PVC for persistent volume claims. Let's do PV. Yep. So we got that. We got the claim. And if we go back to the control panel on DigitalOcean, and if we excuse me, what are you doing? Wow, that was weird. That was extremely weird. Go to volumes. We go to volumes. Hopefully we should see the 3 volumes being deployed, and they're bound to the droplet, so they're essentially just, and if the nodes go down for whatever reason, we'll still have the volumes, and all 8 gigs. You can set that in the settings if you want. That's the default value. If you need more or less, you can change that. Now obviously this is massively over engineered. We don't need that. It's just, again, for demo purposes. So this is done. Great, we're good. Now we can move on to deploying cert-manager. And so again, we'll just copy and paste because it's another Helm release. So boom, we'll take that, we'll copy, we'll paste it, and this one is going to be cert-manager. Again, it depends on this. It's called cert-manager. Chart is cert-manager, and this is going to be jetstack.io. Is it? Yep, charts.jetstack.io. cert-manager. It doesn't need a values file. However, we will set an individual value, which we will call, which is called install CRDs. Yep. And the value is going to be true. We will install that in its own namespace. So the namespace is going to be called cert-manager, and then we'll create that namespace. Cert-manager. No, it's true. That's a boolean, and then we'll pin the version for good measure. What are you doing? Version equals 1.8.0. It's a good. I don't know if it's good practice, but you know, if you know that there's a version that works well with your Kubernetes cluster, well then you can pin that, and then because if you don't specify the version, it's always going to install the latest one, so you may run into, you know, surprises if there are breaking changes or whatever. So it's, I guess I see it as good practice, but I don't know. All right, so we'll do tf apply. We'll do yes when it prompts us, please. In the meantime, I'll do watch kubectl again, and in the cert-manager namespace, we'll do yes. In fact, I'll do kubectl get all. And soon enough, we'll see services and you know, by the way, CRD, the custom resource definitions, the things that well, it's all popped all at once. But yeah, the custom resource definitions, you can look up what that is. They're essentially just, well, just that, custom resource definitions, that, because you know, we have services, we have deployments, we have stateful sets, blah blah blah. Well, cert-manager uses its own resources, objects like issuers and stuff like that. Let's actually go to cert-manager.io like that, and as you can see, if we go to the documentation, you see kind issuer, kind certificate, blah blah blah. These are essentially just their own custom thing. So it's all up and running, right? Running. Everything is running and ready, so that's great. And so, well, now we can set up TLS. But before we do that, we want to actually deploy our app. So we'll go back to our Kubernetes directory, go up one directory, and we'll touch Kate. So we'll do config map. Actually, let's cd into Kate, and then we'll touch config map, deployment, and service. All right, so we'll do config map, and so we'll do config map. We'll create one. We'll call it pocket config. Namespace is going to be the default namespace, and the data, this is going to essentially hold that data for us. So pocket db host, and then pocket db user, pocket db name, pocket db tz for time zone, pocket base URL, and then pocket db env. Alright, so env is going to be production, base URL is going to be https :// pocket.us. The time zone is going to be Europe / Paris. Name is going to be pocket prod, and be careful because the db name, db user, they absolutely must match the values that we've set in the psql values YAML, and the user was Fisher. And the host, now the host is going to be the pg pool service. So if we do kubectl get svc, we'll need this one. It's listing on port 5432, so that's the one we want to connect to, and we will do just that. So we'll do that. In fact, to test that it works, we will do kubectl port forward, and we'll do Postgres -PostgreSQL -ha pg pool, and so we'll essentially just do that. And if we go here and we do pgcli what was my password? What was the password? Oh, xyz. Boom, we're in, it works. So no issues there. Now, okay, so we need to create now the deployment. Now for the deployment, I'm not gonna bother, I'm just gonna, I'm essentially just going to copy the one that I already have. So dev pocket.us infra Kate's deployment, and I'll move that to Kate's deployment. Alright, I'll show you. So if I open the what happens? Deployment.yaml. Alright, so it's called Pocket Prod. The label is Pocket API. We're creating 3 replicas. We're pulling the image from Docker, and we're setting the environment variables from the config map. So the db host, db user, db name, time zone, base URL, the db environment, and the password. And the password, we didn't put the password in, and if you look closely, it's a secret key ref, not a config map ref. And if we do kubectl get secrets, get secret, we have this secret name. So if we do kubectl describe secret this, we have where's it? Is it the one? That's not the one. Hold on. Maybe that's not the one. No, that's definitely that. So let's do kubectl get secret like that, and then output YAML. All right, yeah. So if we describe that, all right, let's just pipe that to head. Okay, and as you can see now, we have the PostgreSQL password. PostgreSQL -password is the password for the admin user, and this is the password for our user. So we'll do this. Nope, that's not what we wanted to do. We want to copy the base 64 encoded version. We'll do that. Echo -n, we'll pass that, and then we'll do base 64 -d. Nope, that's not the one. That's the one. So this is the password for the admin user, and that's our password. So my bad. I'm a bit distracted because I'm hungry. So okay, now we have our password. And I'm curious, so let me do pgcli again. Let me actually get that. What was that? I think that's not the one. That was the one. Let me do pgcli this. And I don't know, let me just do Postgres. I think it's admin. No, maybe it's admin. Let's just do admin. Oh, let's first do kubectl port forward. And then let's do that again. I just want to see if it works. Nope, there's no user admin. So let's do Postgres. Postgres. Oop. Alright, well, whatever. But this definitely points to a it's a legit password, but I don't know the username. Anyway, so we will now deploy our deployment. So kubectl apply -f gates deployment.yaml, and let's just do that. Kubectl get pod pod. All right, let's deploy that, and hopefully this is gonna work. Hopefully. Yep. All right. So config error. I was expecting this, so we'll do kubectl logs. Bad request. Well, that's not helpful. Let's try this one. kubectl logs. That's not helpful. Maybe this one. kubectl logs. Alright, that's not helpful. So we'll do kubectl describe pod this. Alright. Config map, pocket config, not found. And the reason why it's not working is because we have not applied our config map like the absolute melon that I am. So I will apply it. And so hopefully now it should work. Yep, it's running. This one's running, and this one's running. Will it run? Yep, it's all running. Great. Okay, so we will create a service. So we'll just go to service. We'll do the service thing. We'll call it pocket prod service. That's the selector is going to be pocket API. We don't need a name. Port is going to be 4000. Target port is going to be 3000. So the target port is the port on the container on the pod. Okay, so this looks good to me. So we'll essentially apply. So kubectl apply -f service. All right, so we'll do svc. And I have my pocket prod service. So if I do kubectl port forward this, all right, so we should be able to test http localhost 8080. By the way, I've not talked about this, but essentially it takes a post request with the only key being origin. And this points to a, actually let's just do http post, https, http localhost 80 /API/pocket, and origin is going to be, let's find a long link. Let's find a really long link. Let's go to Amazon. I think this one was super long. Yep. Oh, look at this. Look at this. So we'll just wrap that into quotes. Right. And then we'll post, and hopefully this should give us a response back. Boom, we do. And as you can see, it creates a short URL, pocket.us/this. And then we can query the public ID for this. So we can do HTTP get. HTTP is HTTPy, So if you're not familiar with this, you can download it for yourself. Let's go back. HTTPy. HTTPy.io is a sort of a nice replacement for curl. Anyway, so I can do HTTP localhost 8080/API/pocket /public ID, and boom, we get the pocket code. So that's great, brilliant. Okay, so now is the time to set up TLS. So all right, so now we'll need to follow the instructions on cert-manager. So we'll create we'll issue an Acme certificate using HTTP validation. So we'll create an issuer. I mean, you can read up on the documentation. There's a good video on YouTube about tons of videos, but there's a particularly good one on this by someone named DevOps Dude, I think, DevOps Guy. He's really good. He explained everything, so in detail. So if you want to look at that, have a look at that for yourself. We'll just go to our Kate directory. No, let's go back to Terraform actually. Let's use this as our Kate directory. We'll create a TLS directory, and inside that we'll touch issuer certificate and Ingress. So we'll open the Ingress. Let me actually vim here and then find the issuer file. Okay, so now I can paste what I've found, and we'll do a few adjustments. The first being the API version. We'll use the v1. This is not going to be staging, it's going to be production. Again, you can name this whatever you want, but I'll keep it simple here. We'll use the actual URL, not the staging URL. Make sure you have an actual at gmail.com. Make sure that your email is valid, because in production it will do the check, and if it fails, you'll get an error. So this is going to be production. This is the secret key reference we'll use in our certificate, and we can remove that and just leave that as is. Right, so now we can do kubectl apply -f Kate's in fact, we'll need to change this to be cluster issuer, because if we leave it at that, we'll need to add a namespace, right? So this is going to apply to all namespaces. So we'll do Kate TLS issuer. All right, it's created, and so now if I do kubectl get issuer, no, get issuer, I can end cert-manager. What happened? What exactly happened? Oh, it's not working. kubectl get all, and a kubectl get issuer. Why is it not working? Well, that's very interesting. All right, what am I missing? What am I missing? kubectl apply -f gates TLS issuer.yaml. Cluster issuer does. Oh, it's not issuer, it's cluster issuer. So we'll have to do this, I think. Cluster issuer. Yep. And it's not ready. I don't know why it's not ready. Kubectl. Well, actually, do you know what? Let's just kubectl delete cluster issuer. And let's encrypt production. Right, so we'll delete that. we'll go back to using the issuer, and then we'll define the namespace, I guess, as default. Whatever. So we'll do apply this. Now, hopefully, maybe my email address is wrong. Let's get issuer. It's not ready. Should be ready. Alright, let's just. Alright, whatever. Let's move on. Actually, now I'm a bit confused as to why. So let's do describe issuer. Let's encrypt. Let's encrypt production. Initializing dial lookup acme02 API let's encrypt.org. So what is the problem with this? Oh, the URL is wrong. So I wasn't wrong. Let's go back to create the class issuer, and it's acme-v02. So again, kubectl delete issuer, let's encrypt dash production. All right, and then we'll do the whole thing again. Resource not found for namespace default. It's cluster issuer. Do that again. Thank you very much. Boom, boom. And if we go and get the cluster issuer, it is ready. Brilliant stuff. Finally. All right, so now we can create a certificate. And so for the certificate, we will actually we'll just copy and paste the whole thing from the documentation. So if you scroll down, we'll get the code block again, v1. So this is going to be pocket.us. Secret name is going to be pocket.us.crt. It's, I guess, common practice to append it, like to do pocket US TLS. I just don't like that because essentially the secret will contain the certificate, so it's more fitting to call it cert. The issuer ref is production because if we go back, here, the private secret key ref, we've named it let's encrypt production. So that's that. Common name, that's our domain name. And again, we'll go pocket.us. Now be very, very careful to not put any subdomains you have not created records for, because this will take you forever to debug and stuff like that. So only add subdomains for actual subdomains you have added records for, right? And essentially it will, I believe, create a certificate for every subdomain on that list. So yep. Now if we do watch kubectl get ingress, you will see the magic, well, not the magic, but you'll see the whole thing happen in front of your very own eyes. So kubectl apply -f, and we'll apply the certificate, and soon enough you'll see an ingress pop up here, hopefully very soon. Please, come on. All right, well, let's kubectl get certificate. Why is it not working? Let's do why is it not working? Pocket.us.crt. Let's encrypt production. Common name is this, DNS name is that. So it should be working, so I don't know why it's not working. Kubectl describe certificate, and we'll do pocket.us. All right. It doesn't seem to be a problem. Oh, reason does not exist. Okay. What's that about? Issuing certificate a secret does not exist. Okay. Do we have pocket.us? No, I think it works. It should work. So what is wrong with our thing? All right. So this is weird. This is extremely weird. Let me cat my own and see what we've got wrong. Cluster issuer. So we'll add the kind of cluster issuer. Okay, so now if we get this, so show you that. Let's watch the Ingress. And then let's reapply. So apply this. Now hopefully, yep, boom, it's working. Great. All right. So this is going to do its thing. It's going to query, I think, the Acme whatever server. It's going to request a certificate for the whatever DNS names we've listed here. And once it does its thing, we'll add our own Ingress manifest, and then we'll be good. Hopefully good to go. Hopefully. All right. So it's pulled the address. Great. Now it's gone. It's been deleted. Great. So now all there's left for us to do is create our Ingress. So we'll do Ingress TLS. All right, I'm back. So yep, so we've created the Ingress Ingress controller, Ingress manifest. So we need to give it a name. I'll go back to my notes. So this is going to be pocket US Ingress. Secret name is going to be pocket.us.crt. In fact, we can verify this by doing kubectl get secret, and there is one now of type kubernetes.io/tls. Cool. So I don't think we need this. Actually, yes, we do. So we'll do that. And we'll do that. And then we'll do this. Like that. This. That's going to be pocket.us. Okay. And then the service, we've called it pocket prod service on port 4000. Hopefully this is going to work. So if we do kubectl apply gates TLS ingress and we watch the ingress. If we get an address over here, we will know that we are golden. So let's wait it out and see if it works. It should, hopefully. We've had a few hiccups, but we've been able to overcome them. So there's no reason why this wouldn't work. Please. If not, I'll use my reference and I'll see. Oh, we've forgotten something very important. The annotations in kubernetes.io/ingress/class of nginx. So if we apply that again, this is now going to work. Hopefully. Let's actually do it again. It should work. Why is it not working? So the secret is good. Namespace is default. Annotations are port. Oh, yep, it works. Brilliant. So the address popped up. So it all works now. So if we do HTTP post, HTTPS pocket.us, and we'll do that, it works. We get an error false. That's created. I'll do a quick demo here. We will be redirected to Amazon, so that's great. And let's just do that with HTTP, not HTTPS, and see if we get redirected. I think we'll get a 308. Yep, 308 permanent redirect, and the location is HTTPS. So this is done. It all works. It's great. Yeah. Obviously this app is very bare bones. I will maybe add logging and caching and rate limiting and all that good stuff, maybe on stream actually, so you can see me code and go. And then, well, the last thing there is for us to do is to destroy the whole infrastructure. And the cool thing about this is that it's reproducible now. So we could just destroy the whole thing. Well, we're not in the correct directory, so we'll have to do it here. If we do tf destroy, auto approve, it's going to destroy everything, and then we'll be able to get it back up and running in a snap, just like that. And so once it's done destroying, hopefully we will have the there will be one thing left to do, because it's going to essentially destroy everything except the volumes. And this is I guess a security policy. Well, it's already destroyed the Kubernetes cluster. If we go to networking, the load balancer should be gone. Yep, it's all gone. So no domains, no load balancers, no nothing except the volumes. And this is to avoid any data loss, so we could essentially just recreate a Postgres high availability cluster, and then we could provide these volumes as sort of volume claims. Well, I guess no, persistent volumes, and then we could reattach them to the nodes, and we won't lose the data. So we'll delete them manually And as I said, we could have created them in code, and then we would have been able to assign them and sort of destroy them as we destroyed infrastructure. But yeah, that's it. That's it for me. That's it for today. How long have I been streaming for? I sure hope that this was, I mean, that the sound was good enough this time. So yeah, if you're watching this on YouTube, we'll like the video, I guess. If you've liked it, share it. Consider subscribing. Please don't forget to use my link. That will be in the description. And with all of that, I will see you in the next one. So have a good one.